On almost every ACT, there is going to be at least one question involving matrices. In this video, we are going to go over the basics of matrices. We'll start with the definition of a matrix. A matrix is simply a rectangular array of numbers. We can see in the top left diagram that I have a m by n matrix, where m stands for the number of rows and n stands for the number of columns. The positions of each value in the matrix are denoted by the subscripts. So if I had you look up value 1, 2, you would know to go to the first row and to the second column. Like many other things, we can add and subtract matrices. However, in order to do so, the matrices must have the same dimensions. For our first example, we have two 1 by 2 matrices, and we want to add them together. So all we need to do is add 1 and -3. That'll give us -2. And then for the second value, we add 2 and 6. And that gives us 8. When we try to add the second group of matrices, we notice that we have a 1 by 2 matrix and a 1 by 3 matrix. We can't add those because they don't have the same dimensions. So this is undefined. Next, we have two 2 by 2 matrices, and we want to subtract them. When we subtract, it's important to carry that negative sign through, just as if we were distributing something in parentheses. So what I'm going to do is I'm going to switch this to a positive and change all of these values. So now we have 1 plus 1 is 2, 3 minus 4 is -1, 6 plus 3 is 9, and 2 minus 2 is 0. We can also multiply matrices by a scalar value. This is really simple. We simply take the scalar value and apply that to each value in the matrix. So here we have 3, a scalar, times a 2 by 2 matrix. So we're going to multiply each of the values in that 2 by 2 matrix by 3. That will give us 3, 12, 6, and 18. We can also multiply multiple matrices together. However, if we're going to do so, we have to follow specific rules. First, the order matters. Matrix A times matrix B does not necessarily equal matrix B times matrix A. Next, the number of columns of the first matrix must equal the number of rows of the second matrix. Otherwise, we'll get something that is undefined. Next, the final dimensions will be equal to the number of rows from the first by the number of columns from the second. And last up, the values in the final matrix are dot products of the original matrices. So if we had an A by B matrix and we multiplied that by a C by D matrix, B and C must be equal because the number of columns of the first must equal the number of rows of the second. Finally, the dimensions of the final matrix are going to be A times D, because that will equal the number of rows from the first by the number of columns from the second. Now that we have reviewed the rules for multiplying matrices, let's do an example. So in this example, we have a 2 by 2 matrix, and we're multiplying it by a 2 by 3 matrix. So first, let's make sure that this is going to be allowed. So we're going to look at these two values here, and we see that they do match up. So this is a valid multiplication. Next, we want to know the final dimensions of the final matrix. So it's going to be 2 by 3, because the final dimensions are equal to the number of rows from the first by the number of columns from the second. Now we can do the dot product calculation. So when we do dot products for matrices, what we're going to do, we're going to look at this first row and this first column. So what we're going to do for the first value in the new matrix, we're going to take 2 times 2 plus -3 times 0. So we can see that down here. So 2 by 2 plus -3 times 0. That's going to give us our first value of 4. Now we're going to move along to this second column. So we're going to do 2 times 1 plus -3 times 3. That's going to give us a value of -7. And then finally, we're going to look at this third column. So we're going to take 2 times 2 plus -3 times 1. And that's going to give us 1. Next, we're going to ignore this first row, and we're going to take a look at this second row. And we're going to do the same exact thing that we just did. So we have 3 times 2 plus -1 times 0. And that's going to give us a value of 6. Then we're going to do 3 times 1 plus -1 times 3. And that's going to give us 0. And last, we're going to do 3 times 2 plus -1 times 1. And that'll give us 5. So our final matrix is going to be right here.